Hi everyone, in this video I'm explaining use case of Hadoop by processing very large files using Java. Its size varies from 25 MB to 3.6 GB. So all the classes, sample, everything used in this video can be found in this blog, and I mentioned the link in the description. Okay, so what basically it does is you'll have one CSV file. It contains data of player name, which year he played, and what is the club he played, and how much run is scored. So what it does is it will process each and every CSV file, and you will find like in each year who scored the maximum runs and how much what is. Okay, so this sample is I got it from Hortonworks. Okay, and currently what I am doing is to generate a very large file. I'll use a CSV creator that will create a data for me. Okay, so first thing is I'll create some very small file using this thing. So CSV will be created, and if you check the size of the CSV file, it has some 10,000 rows. Okay, then size will be around 1 MB. So I'm going to process this thing. Okay, so our first use case will be I'm using one mapper. What it does is it will sort all the CSV file and get one map based on key and value. Here the key is year, and value will be the run scored. Okay, so it will process line by line, and it will check that mapper has this here like as a key. If the key is found, it will append one value to the current year, else it will create a new value. So this is very much simple Java code. Okay, after that it will go to the reducer. In the reducer, what it does is it will find out which year maximum run was scored. Okay, then if it's that found, then it will add it to the output with the key and value. Okay, so the first thing is I'm going to process this thing using Java standalone 2.csv file. So it's like it's done very much fast. Okay, it's only one MB file. So we'll get the output here. In the output, you can see in this year, this guy scored the maximum runs. This is the run, and it will sort till the last year, which I put it in the CSV creator. Okay, and the next thing is I'll process the same file, different file with a 25 MB size. So let's see how it's working. Java standalone 25.csv. So it's became slow, but still is doing the work. So it will go through each and every line, and will get key as a year. Then we'll put all the data. Okay, so this process is like a time-consuming one. Okay, and then now it is over. Then it will do the reducing part. Reducing part, nothing but it find out the which like a player scored the maximum run. So if you say that 42 seconds is required for mapping and 2 seconds is required for reducing. Okay, now I'm going to process one 400 MB file, which is like it will have some much like 4 million records. So let's see how it's performing. It does it for some particular memory, like what you can say 5% of this thing, around like a 400K. It went fast. Then what will happen? It is became slow. Yeah, this is like almost stuck. Okay, I'm going to pause the video now. Okay, now like it took some 8 minutes to finish it, and during that time you can see that heap usage went to very high level, and other heap parameters also went to very high level. Okay, and so what it does is understand is that it has some specific limit for one object. If the one size of the object is more than some space, some size MP, then processing became slow. Okay, and if you plot this to one graph, you can see that with this setup you can process only up to 500 MB, and that too it will take around like 10 minutes close to. Okay, now the next thing is so instead of this, to overcome this thing, what I will do is like I will split this object, big object, into smaller parts based on the line number. If the line number is more than 10,000, it will create a new list. Once the new list is created, a new tree map will be created, and it will add it to the one mapper list. Okay, then we made some slight change in the code in the reducing part also, to iterate to all the a list of maps. Okay, so let's see how this is performing for very small files. Split 25.csv. So it's pretty much fast compared to last one, and it needs some time for the reducing part also. Now what I will go to the 400 MB file. Okay, it needs some time, but still it is much better than the like a single object one. Now once split the tree map into list of objects based on the line number, the performance is improved very well. Okay, so it took some 29 seconds for mapping and 3 seconds for reducing part. Okay, so if you plot this thing to the graph, you can see performance is pretty much similar. Okay, and it can process up to 3.5 GB. Okay, around the span of 200 seconds. That means more than 3 minutes. So currently only one thread is reading the file system. So I decide to improve this performance. So what I does is like I created one. I tried to have a multiple thread to read one same file. The problem of that one is like it is a very bad design. Like if you have some multiple threads to read one single file, like it can read up to 25 MB or 30 MB file. After that it will be fail. So I'm not plotting any graph or doing this demo. Okay, and the next case I did is I'll do like a different threads for the mapping. So currently only in this code only one thread is doing the mapping work. So instead I'm planning like once a file read is done, there will be a lot of threads created, and those threads will be do the mapping. Okay, so here what I did is I created one new class to deal with the threads. Okay, in the main class it will go through the each and every line, and once a line number is up, became some particular value, it will create a new thread, and it will do the same mapping function only. So once that is done, it will create some list of tree maps, and it will do some combining action here, and finally it will do the reducing part. Okay, so what I'm going to do is I'm going to run this code for 125 MB file. So you can see like it created 4 threads depending upon the size, and it's ran faster than use case 2. Okay, then what I'm going to do is I'll increase the file size. So it will read the file once one particular number of line number is reached, it will create a new thread, and a new thread to the mapping simultaneously. So you can see how much time it took for how many threads I created and how much time it took. So it was pretty much fast. Okay, so main advantage is we are able to do the mapping simultaneously. So here this number is not correct, but it took reducing time became more, and it took around 33 seconds to finish it. And if you map this thing in the graph, it say that it has a very good performance till 800 MB. Then the performance will become drastically reduced, and you will get a out of memory exception, and that can be overwritten by providing minimum and maximum memory for JVM, but there is a limit for that also. So I'm going to see process one 300 MB file, 3.3 GB file. I'll check it like cat1.csv wtz file. So it needs a lot of time to read in the shell also. In the meantime, I'll process everything parallelly. Time Java thread.csv. So it needs some, yeah. So what it does is like it's during reading the process also it's creating a lot of threads. Okay, so what is going to do it works fine for some 68 or I think yeah, now you can see performance going, some threads are taking more time. Yeah, now like after 120 130 number of threads, so it will be some in memory it will be around 400 MB. Then performance became very bad, and each thread is taking some 4 seconds to finish it. And what it's going to do is it's going to crash it, okay, because I didn't pass any JVM memory value. Yeah, I think CPU is going to happen. I'm going to stop this thing. Yeah. Okay, so this is going to happen. It has some 35 million records. This is the graph with it can be used for some 800 MB value. Then after that the performance will become very bad. Yeah, it's not a good idea to read the same file using different thread. So what is the best solution? So one solution is we can split those files while storing itself. So what I did is I split same file into 2 parts, and I'm going to process this thing with a say Java. Okay, for that one of the best approach is create one RMA object. So one RMA object will read this file, and normal IO other normal Java thread will read second part. Okay, so that is I created one RMA object. To run this thing, you have that steps are mentioned in the GitHub. Okay, then I will run the RMA registry now. After that I will run my server. Okay, yeah, fine. There is a slight modification in the code. The first thing is we will try to contact the RMA object. Okay, so here itself we will start one thread only to read the one block of that file, part 1, and part 2 will be read like a normal operation. Okay, let's see how this is performing. Okay, so I'm going to run this 50 MB file. So it is kind of fast. Okay, now I'm going to increase the okay. So what I did is I created one 700 MB file, and I split into 2 parts. Okay, now I'm going to process this thing. Yeah, my client CSV. The first, so first thread will be will read part 1, and other one will read part 2. Okay, so it is going now. So in one thread, that means like one in the RMA object it's able to finish in 21 seconds, other one able to finish in like 35 seconds, but here reducing part will take more time. Anyway, we are able to finish this task in 42 seconds. Okay, and if you plot this thing to the graph, okay, this works perfectly fine up to 1.5 GB. Okay, which almost double performance with the use case 1 if you compare the use case 2, sorry. Okay, but after some time the performance will become very bad. Okay, so then comes to the next point, like here what happened is one RMI object is running on my local machine, okay, and other thread is reading that same file. So instead, if you split this job into multiple machines, like uh, this main client will be running on one machine, and other two RMI objects will run on different machines. Okay, in that case, and split those files into those two servers. Okay, and perform the task. So you will get a much more better performance. Okay, so in the last demo, what I'm going to do is I'm going to run 4 RMI objects in Amazon Web Service. Okay, let's do the exercise in AWS, that is Amazon Web Service. 4 machines. Okay, I made some changes in the code. I will call for 4 RMI objects like this. Then I'll make sure that each status a different threads. I'll make sure that each thread status is done. Then only it will do the combiner and reducing activity. Okay, I split the file. I kept it in the different machines, all 4 machines. Okay, you can see this is the same file in this location also. Okay, so what I'll do is I will start the RMI process. Okay, the first thing is, okay, I'm starting RMI registry process. Each machine. Then I will start the RMI registry to listen in 5000 port. All 4 machines. Then I will start my server. In background in my main machine, where my client code will run. Other machine without doing background. Okay, now I'll run my code. It will do all the mapping and reducing activity for this file. So I split all the files into 4 parts and kept it in this machine, part 1 in this machine, part 2 in this machine, part 4 in this machine, part 4 in this machine. So you can see in each machine activity is recorded in only 11 seconds, and reducing activity took 6 seconds. So it recorded only 18 seconds to finish the task, but while normal code will take around 1 minute to finish. Okay, so we will take this, we'll verify this thing, that output of this file will be copied into 4 node. Okay, now I'll run the standalone code. Okay, so this is the graph which for the 4 RMI objects. You can see up to 800 MB the performance is really good. You need only 20 seconds to finish it, under 20 seconds. But when the size of the file in one block increases, performance decreases. Okay, so in standalone mode usually it will take around 1 minute. So like while distributing the loads to different nodes, we are able to increase the performance of the system and capacity of the system also. So this is the core concept of Hadoop. Like it store the file in a different, split the file in a different machines and do the process in parallel way. Okay, took around 1 minute. So I'll compare the output. So both output look same. And this is a graph. put everything in a single graph also. Okay, so I put the results of all the tests together in one graph. So in AWS it can process up to 800 MB. So put the new graph with the 800 MB file size, and when there is a more RMI objects, there is a better performance. Okay, so what this shows that when RMI objects are increased, the speed of the processing capacity will increase, and this is the basic concept of Hadoop. Hadoop uses a HDFS file system. It's nothing but it will split the files and store as a block in a different node. We call it as a data node, and all the splitting and location of files details, which are known as a metadata, will be stored in the main server, which is name node. So name node is the most critical part of the Hadoop file HDFS file system. Okay, and we use a MapReduce method, which uses map every key as a key and value, and reducer will process those mappers setting by the mapper. Okay, so Hadoop works such a way that it can do the parallel processing. So mapper and reducers can be done in a different metadata at the same time. And if you want to increase storage space of one Hadoop HDFS file system, you can simply add one node. And one node in the sense it will be a new machine. Okay, and comparing with the RDBMS database, which is I use Oracle 11G in a 4 GB RAM machine, 4 GB VM. Okay, so what happened is to upload 800 MB files, like 8.6 million rows, it need more than 1 hour. And the same query which you used here, the query is, this is the query, it's a joint operation. It took 13 seconds to run in DB, and took 15 seconds to finish entire task, including the connection initialization and writing upload file. So when you compare the best output case, we cut it from 4 RMI objects, that's like a 4 node cluster of Hadoop. We got 18 seconds for 800 same file. So RDBM is still processing like a best in processing the linear queries for certain memory or a space. Like if its data is more than some like 1 terabyte and all, RDBM is going to crash. So then in that case only that Hadoop comes to picture, because Hadoop can increase the storage space as well as the processing capacity by adding the new nodes. Okay, and one more thing of database problem, it's always need a data in a structured format. It won't take any semi-structured format like XML or JSON. And uploading in this case, it took more than 1 hour to upload 80 million records. But the same can be done in HDFS is very less time. And okay, and the last point is Hadoop is not a replacement for RDBMS. As of now, Hadoop can do any transaction level operation like background operation or ticketing booking. Okay, for that still we have to use RDBMS. And main power of Hadoop is like a distributed file system, and those distributed files can be processed simultaneously using MapReduce. Thank you.